Hello everyone, this is Suresh Kumar working as a assistant professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we will discuss very important topic. In the previous lecture, how to recharge of the artificial recharge of the groundwater and how to increase the water levels in the groundwater will be discussed. And today we will discuss about the well and well hydraulics. What is the behavior of the water in the ground level, and also the increasing decreasing levels, how to calculate the different type of the methods can be applied will be discussed today. So let us see that one, the well and well hydraulics. What we have to learn, the well hydraulics is the main hydraulic structures of the ground obstructions from the potential geological formations. And then the purpose of the water wells is to be extract groundwater, and from the saturation of the zones of the different type of the zones will be saturated zones, and the agricultural, it can be used for the agricultural, industries, any of the other purposes we have to be used. The choice of the well-shaped dimensions of depends upon the piezometric levels and permeable or semi-permeable of the impermeable or impermeable. Semi-permeable or impermeable. So then we recharge of the positions of the, whether it is direct or indirect methods. The choice of the well hydraulics or dimensions of the piezometric level, whether it is shallow levels or a deep levels. The subsurface of the geological layers of the permeable, semi-permeable of the impermeable, recharge possibilities of direct or indirect. So the first classification of the wells based on their diameter and their large and small diameter of the wells. And large diameter wells are dug usually in unconfined and shallow aquifers, and the small diameter of the wells that penetrate big depth they are suitable for the deep confined aquifers. Before word has been we used as aquifers, let us see what is the aquifers, how the behavior of the ground, how the water can be stored in the ground and can be. Let us see that one. What is meant by aquifer? Aquifer is a geological formation under the water, being the permeable rock or impermeable rocks of the materials like gravel, sand or silt, which the groundwater can be extracted using the water levels. So the study of the water flow in aquifers and the characterization of the aquifers is called hydrology. There are the two types. The first one is confined aquifer and unconfined aquifers. Why we have to discuss in the recharge and groundwater levels, the storage of the water will be mainly depends upon the aquifers. This is nothing but the stories, the water can be stored by different type of the aquifers. So this is the aquifers, unconfined aquifers and confined aquifers. Let us see then the water level of the artesian wells we have to be discussed in the previous. Next, the surface water can be used like that, the groundwater, and the confined layers of the aquifers can be like that. Let us see the geological materials from the confined and unconfined aquifers is the significance of the water cannot be moved and located in the unconfined aquifers. The above or below of the wells known as confined aquifers. Let us see that one is the diagram. We can understand easily. The unconfined aquifers is there and aquated and confined layers of the in between these two layers. And in the bottom we call as the confined aquifers. So confined aquifers compulsory have to be water can be available. Generally have to be water can be acquired from the confined aquifers. Okay, that is the main purpose of the aquifers. In this diagram you can understand easily the confined aquifers are those which can be impermeable, dirt or the rock of the layer exists, prevents water from seeping and into the aquifer. From the ground surface is located directly and above. So these are called recharging. Let us see in the diagram here understand The recharge of the groundwater here, see in the upstream side, the water can be allowed and which also enter inside the bottom, and the water table is there. So in the water table, the catchment area can be water can becomes, and which is in the groundwater levels is confined aquifer. So what about in the confined aquifer? The aquifers, which is the let us see the unconfined aquifers is there. In unconfined aquifers is aquifers, the water can be stored in the level which is infiltrated, or any percolated water can be penetrating of the water can be stored here. So it is whether there is a confined aquifer, what happens? It is the two impervious layers between these two we call as the confined aquifer. So that is called unconfined, and this is the briefly about the confined aquifers and unconfined aquifers. Let us see that one. The water tables, the water wells we have to be discussed here. Let us the water table of the wells here. Different type of the wells we have to be constructed for the storage. This is the water can be acquired from the low water level of the depth. This is called from the acquired from the unconfined aquifer. And artesian wells. This is also one of the artesian wells. What artesian wells will also can be acquired the water from the ground level. Based on these levels, we have to be concerned what is the use of them. These can be wells can be used for the what I told, the different type of the uses you have to be find. Whether it is agricultural purpose, maybe drinking purpose, or any other domestic or a industrial purpose, whatever it is, the water can be by using the wells. It can be the water can be acquired. The groundwater surfaces, the water cable has been the confined and unconfined. This is the briefly about the confined, unconfined of the aquifers. So that is the next. This is also the same regarding the picture, which is the aquifers increasing of the unconfined aquifers and unconfined aquifers are non-artisanal wells, not artisan of the wells here, and water table the water can be acquired from the water table, and flowing the artesian wells can be constructed here from the water can be acquired. This is for suppose this is also the aquifer, and the streams of the water can be here, and also the confined artesian aquifers also be constructed. The aquatar confined layers of the bedrock, and the bottom will be the bedrock. So this is the bedrock. So this is the briefly about the whatever the water can be acquired through the wells. Different how the water wells can be acquired, and where you have to be dig the wells. Will the different type of the aquifers we can be acquire the water based on the requirements and the geological conditions. It means the water can be available of the different layers. Let us see the aquifer as a layer of the, as discussed, and the unconfined aquifer. The unconfined aquifer is nothing but aquifer is sometimes also called the water table. So just water table is there. The periodic water is their upper boundary is the water table. When water is can be directly in between the surface and saturated zone can be aquifer is called unconfined aquifer. Let us see that one. So that you can understand unconfined aquifer here. So water table can be zone from the bottom of the on top of the confined aquifers. So this is the impervious layer is the bottom, and the water can be allowed in the top. This is called unconfined aquifers. Next, confined aquifer. The confined aquifer is the aquifer. It is also be a water bearing substance that which the have the block the formations of impermeable and all relative impermeable of the rock soil, also known as artesian aquifers. We call it as the artesian aquifers. Okay, the formation of the impermeable of the layers of the relative impermeable of the rock. It is also known as the artesian aquifers. So this is called is a aquator confined aquifer, unconfined aquifer. Artesian borewells is like that. So water which is acquired from the aquacloud or confined from the confined aquifer, the water can be acquired. So the bores generally aquated, the water can be level from the unconfined aquifers, and the water requirement is more. What happens? It can be acquired from the unconfined aquifers. So properties of the aquifer: the porosity, specific yield, and specific retention, storage efficiency, permeability of the transmissibility. These are the properties of some aquifers. So the porosity is nothing but the voids between the soil particles, the empty space between the material of the fraction, and it is more. What happens? The water can be absorbed directly in the bottom to infiltrate, and also the ranges from the 0 to 1 has penetrated between 0 to 100%. The porosity of the surface of the soil has the typically decreased by particles of the size. Next, specific yield. What is meant by specific yield? In the specific yield, what happens? The quantity of the water which has the unit of the volume aquifer, and after being that saturated will the as the gravity, it is expressed as the ratio of the penetrated and the volume of the aquifer. The specific yield is measured in the water table of the wells. That is called specific yield, we call as. So field capacity. What is meant by field capacity? Field capacity is nothing but the amount of the soil which is the water can be contained of the soil after the water has been drained. The physical definition of the bulk water of the content of the retained of the soil. Next, specific retention. Retention of what is meant by specific retention. The rate of the volume of the water given the body of the soil, and it can the volume of the body itself. It is usually expressed as percentage. So permeability, as we know very well, just permeable which allow the water from the can hold and the effect of the quickly throughout the soil. That is called permeability. The ability of the water to flow throughout the soil, which can be referred as the soils of the permeability. So this is the sum of the some particles is given here. 2 minutes, 200 hours. 200 hours. What happens? This is the permeability of the soil, which is acquired from the more water from the transparent from the particles at the ground level. This is the sum of the comparison between the 1 meter wall jar is taken. One is kept as the gravel, and the sand and the silt is there. The clay is there. So which one is maximum? The water can be penetrated as usual gravel, and again sand and silt and the clay materials. So what happens? The clay materials particles is the minute is the gap between these particles. What happens? It can be hold of the water. That is the important. So how much the water can be hold, and particular depends upon the soil conditions is also there. Next, transmissibility. It is the measure of the ratio of the response amplitude of the system study, state vibration, and to be exertion of the amplification. This ratio of the force of the displacement velocities as well as the accelerates. So aquaclude, very very important. Aquaclude. It is the solid type of the materials of the area underlying of the aquifer. This impervious layer. Aquifer pressure could be become the confined aquifer. A solid impermeable area underlying the overlying of the aquifer. It can absorb the water but cannot be transmit the water from this one. This is called as aquaclude. So the important point, cannot transmit the significance of the water. Next, aquifers. So aquifers is the impermeable layer of the rock which is the connecting the opening. There is neither absorb nor transmit the water. Next, aquaturd. A bed below of the permeable of the aquifer. It can serve as the storage unit, and this can be groundwater, although does not yield the water readily. So in the Darcy's law, from the majorly explaining regarding the water, how the water can be status in the groundwater. So typically the Reynolds number of the clarify rho v d by u, and rho is the density of the water. Specific discharge can't be for velocity with units of the per time. So this is the some mu is the viscosity of the fluid. So this is radial flow of the confined aquifers. A well, A artesian wells, as we know that. B is the flow wells, and second one, and the third one is the observation well and a frackling well. These are type of the different type of the wells of which is the water can be. So we can be discussed in the briefly in the next. Let us types of the wells. Well, we come to the types of the wells is there. Basically, the wells can be drilled into the ground, excess of the water, the acquiring of the water from the pumps, and also used to the pull of the water from the ground, and has been seen the filtered and particles of the pipe. So this is the different type of the pipes of the dry wells and open hole wells and gravel packed wells and dug wells. So some of the type of the wells can be also extracted of the water from the wells. So today's topic is we are going to be discuss the well and well hydrants. In the previously what we discussed the aquifers. Aquifers is the water storage, how much the water stored, where you have to be stored, where you have to be acquired, how the wells can be constructed, how the water can be expected, different type of wells. So like that we have to be discussed in the previous. Next here the well and well in this topic of the impervious layer, let us see that one. The case diameter wells can be constructed, water table is there, and aquifer and the losses, well losses, and also this is the diagram is easily understand to the initial piezometric level and the final, and this is the 2RC, the well diameter is like here there, where S is equal to storage coefficient as we discussed in the different type of the definitions, storage coefficient, and the hydraulic conductivity is there, K, and T is the transmissibility. So here by using this you have to be well hydraulics. So let's in this diagram what we understand here, the surface of the initial piezometric level, depression zone cone, and the aquifer of the downwards and also well downwards is there, and confined layers, the confined layers aquifer, the storage C, and S is equal to confined aquifer, and storage activity is there, and hydraulic conductivity also there, and T is equal to transmissibility is there. So the based on this one we have to find the levels and analyzing the groundwater conditions and the different condition, different type of the wells we have to be suggested. So that is why we have to be choose. Next, large and small diameters of the wells is the, let us see the behavior of the large and small diameters. In the large diameter, the large and small diameter of the wells are the following: comparison advantages. The excavation of the large, what happens? The small diameter well does not require, but sophisticated machines of the drilling, they put drilling of the machine inside as we see in the previous in the layers or different layers. For large small diameter of the digging of the operational skilled personnel are not to be required. The next one is large diameter of wells. What happens? Large diameter of the wells is depends upon the gradually after the dying of the drought areas. The periods of the small diameter wells are drilled once for all. So it can be in the large diameter of the wells. In the large small diameter piezometric levels is not close on the earth surface. So that is the comparison of the large diameter and the small diameter. According to in the large diameter of the well section, pumps are usable of the ground for groundwater is the surface. Next, large diameter well is rather cheap or to be constructed to maintenance. The maintenance will be almost will be the larger small diameters will be the construction should be the less. And the large diameter of the wells of the rather cheap and compared to the drilling. By drilling machine will be they will give the for feet of the 25, 30, 40, 50 rupees will be charged. But it can be digged up to the wells of the 700, 600, 500 like that 400. So different type of depths they have to be used. On the wells hydraulics, on the other hand, the large small diameter of the suspensible contamination and the pollution. That is a disadvantage. A large diameter wells occupies large space for the wells and digging of the materials. So next, the next point, the largest small diameter of the susceptible and to the contamination of the pollutions. Next, wells of the water levels. The water wells construction include what happens include the selection of the appropriate drilling of the methods and selection of the appropriate compliance materials and analysis of the interpretation of the wells and aquifer performance. So next one is the consider the water as unconfined aquifers and the constant of the well. Prior of the pumping of the well indicated of the static of the table. A lowering of this water level takes place in the pumping. An aquifer is the homogeneous and isotropic of the materials water tables of the horizontal initially and then radial flow of the wells. Horizontal initial, horizontal which is formed, and radially it can be forms to the in the bottom of the ground levels. The shape of the cone of the depression. The drop of the water table of the elevation of the points of the previous static level is called drawdown. We call it as drawdown. Very important definition is called the elevation of any of the point from this previous static level. We call it as drawdown. The aerial extension of the depression is called as the influence, and the radial extent radial of the influence. A constant rate pumping, the drawdown curves develops gradually with time due to the withdrawal of the water from the storage. Next, the phase is called unsteady flow. The water table elevation at the given location near the well changes with the time. On prolonging of the equilibrium of the state, the reached between the rate of the pumping rate and influence of the groundwater edges of the influence. The drawdown surface of the constant and also the position of react with known as operating under the steady flow of the conditions. As soon as possible, the pumping is to stop. Replace the storage cone is depression is made. Good groundwater can be improved the zone of the influence. Why we have to be studied of this one? We have to improve the zone and study the conditions and design the wells in the underground conditions of the different geological formations. And the gradual accumulation of the storage of the level is reached. The storage is called recuperation of the recovery of the unstudy of the phenomena. Recuperation depends upon the aquifer characteristics, and let us see that when the observation of the wells of the, as we discussed previously, this is the wells we have to be radius of the influence or and the different type of the wells, observation of the wells, cone of depression is there. Why cone of depression is there? The water level will be decreases as per the requirements in the underground. So why? Because the water level can be one point into it can be comes under the availability of the water to the unconfined aquifer well screen of the radius. This is the diagram regarding the explain of the well, type of the well, behavior of the wells. Next, in confined aquifers, consider piezometric heads are recovering the take place in the very rapid of the rate. Here, let us see the diagram. We can understand the cone of type of the water where the well. What happened? There is R1, radius 1, radius 2, and cone of radius and the external is equal to 2. Well axis, cone 1 and cone 2. The original water level of the table is there and cone of depression. Original water level is origin is that level is there that it can be entered in the water, and it also going the cone of depression of the water can be also be entered. Well, the development of the flow of distribution about the discharging of the well of the confined, unconfined, and intermediate storage of the study of the state. Next, the pumping of the continuous of the water must be derived from the aquifers of the greater distances from the bore and well of the following items are observed. The cone of depression can be explained what happens. The water which is the behavior from the above the acquired of the water from the underground of the conditions. How the infiltration and filtration, infiltration and percolation will be behavior. Then it can be water can be stored in the groundwater. The radius of the influences of the well increases to the expansion of the cone. The drawdown increment of the point will be the increases with depth of the cone of the provision of the additional head required for the greater distances. The cone expands, the deepest of the slowly with time since the increasing the volume and stored of the water is available with horizontal expansion of the cone. So let us see the diagram. You can understand easily the original water table and the flow line of the flow line will be the like that. Here the We have to be, and so another one, the original water table, and also in the depression of the water table is also there. Let us see that one, the water table which is comes here, and also for development of the flow of the discharge well unconfined aquifer, initial storage, and B is the intermediate storage and steady state flow of the sea. So like the initial storage and intermediate storage and steady state of the flow. What have the diagram will be understand? It can be gives the information regarding the storage capacity of the wells of the water can be stably stagnating. Next, let us see the another diagram, the confined layers of the water piezometric line, and the water table is there. The main well, the water can be the layers which the water can be behavior here. The impervious layer is also there. The piezometric level in the water table. So piezometric level is there, water level is there. So can be understand easily. The water can be flowed from this one, and it can be also be depressed the water of the. But here is some difference between the here the water can be directly into the one, but it can be stored up to the level of the some distance is there to capacity of the wells. So this is also another diagram of the explaining the piezometric levels, how the impervious layers of the water, upper penetration and lower penetration is there. The penetrating of the water can be behave in the groundwater, but the confined aquifer, partial penetration of the aquifers. So study stored for the confined aquifer is there. It shows the completely penetrating the horizontal confined and aquifer thicknesses be confined well discharging the steady flow. The original piezometric heads and the static heads is there. Pumping indicates, and also figure A shows that a piezometric head of the pumping of the well, piezometrical the head of the pumping of the well of the drawdown of the next another diagram is shown the how the water can be flowing inside the flow distribution of the discharging of the confined aquifer. So for this one, the unconfined aquifer QW is equal to Q1 minus Q2. So that is by using the formula A is equal to 2 pi R. We know 2 pi R to be A2 is equal to 2 pi R to be. The bottom is there one, bus outer is there R1, here is R1 and R2 is there. So S1, S2, VW, QW discharge. Velocity is equal to V1, V2, Q1, Q2 is there. So V1 is equal to Q1 by A1 as usual. V2 is equal to discharge by area as we know well. VW is equal to QW by AW. By using VW is always greater than V1, V1 is always greater than V2. Why? Because external will be take it as V2 and R2 will be the greater. So this is also the art is in the wells of the behavior. The aqua fluid is in between these two, pump of the tire to bottom, and Q is the discharge of the water well, and the original piezometric surfaces is there, and piezometric surface under the pumping S1 and S2, and H1 S2 difference between the levels of the different levels of the cones of the depression, and S is the H is the height of between these two, HW F1, and these are the some given the dimensions of the how to find the behavior of the and well storage capacity, and also the storage of the water of the aquifers. The water table can be designed by using the steady state flow of the wells. The piezometric head of the flow, Darcy's law is equal to VR is equal to K into dH by dr by using the formula. The cylindrical surface which is the velocity occurs 2 pi RB, hence they are equating the discharge surface of the wells. The cylindrical surface throughout which the velocity occurs 2 pi RB, hence by equivalent discharge entering the surface of the well discharge, Q is equal to 2 pi RB, K into dH by dr, that Q by 2 pi KB dr by R, that is equal to dH. So integrating the between the R1 and R2, what happens? The corresponding the piezometric heights of the H1 and H2 can be solved. Q by 2 pi R KB in R1 by R2 log, that is equal to H2 minus H1, or the discharge calculation Q is equal to the final 2 pi KB H2 minus H1 and log R2 minus R1. What you have to find what happened? You have to find the discharge of the wells which have acquired the water from the underground. This is the equilibrium conditions of the steady flow confined aquifers we have to be studied. This equation partly known as we call it as Thames equation. Thames equation. In the drawdown of the wells also S1 is equal to H1 minus HW, S2 is equal to H2 minus HW, and KB is equal to T. By discharge calculation 2 pi T as usual, S1 minus S2 log R2 minus R1 from the equation 2, and further it can be zone of the water influence. S is equal to 0, R2 is equal to R, H2 is equal to H, and the value of the R1 is equal to RW, where H1 is equal to HW and S1 is equal to SW. Equation 2 would then equation 3. So that is equal to equation 3 is nothing but 2 pi T KSW into log R into RW, R by RW. So based on the equations of the 2, and what we have to find? We have to find the T value, estimation of the T, and hence K of the pumping of the test for the different type of equilibrium conditions. The equation 1 is alternative forms, and it is necessary that the assumptions of the completion of the wells into the aquifer steady state flow can be satisfied. So the next recharge boundaries is also there. So equation of the equilibrium of the stabilizing the cone of the pressure around the pumping of the wells may be developed several general situations. One of these well aquifer is recharged from the river of the intake and lakes or the rivers, and also the recharge of the region of which is the aquifer and the replenishment. So well hydraulics is we have the as the recharge of the boundary, the diagram is there, the glacial drill of the drift is there, fine sand is there, coarse sand, confined of the clay. These are the some of the layers which are in the recharge of the boundaries. The drawdown of the water pumping of the cone depression of the levels and recharging of the equipment. By keeping of the pumping where the table is can be decreases. By hydraulic gradient of between the groundwater, the aquifers of the water is also be depressed in the river of the channels. So in this one, in the another imaginary infinite of the figure 1b, the introduced hydraulic system of the physical boundary, and as we shown in the previous layer, the image will be equal to the opposite side of the river in the thing. Let us see the see the diagram of the drawdown of the aquifer boundary in the stream is equal to, there is some another aquifer is there, and different levels, different conditions is there, A, B, C, which is already given in the. So H0 minus H is equal to Q by 4 pi WR. By using this formula, you have to S 4 pi T by U1 is equal to R1 square S by 4 pi T. So this is the briefly about the well hydraulics. So next we have to discuss some another interesting topic. Thank you. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.